ZL Engineering Plastics presents a presentation on the food processing industry. The food processing industry is a prime industry sector to target for multiple applications involving engineered plastics. It's interesting to note the definition of food processing. This includes the gathering, grinding, mixing, cooking, conveying, and the packaging of food products. It's a great market sector for various engineered plastics, acetyls, PETs, nylons, PEEK. Those are all within the ZL product line, and a large market share for olefins such as UHMW and high density polyethylene. There's a real opportunity for new or replacement materials that offer better and faster processing, and most engineered plastics provide FDA compliant and are lighter weight, lubrication free, and chemically resistant for the food processing industry. The expression time is money is extremely relevant to anything related to the food production industry. There is always a push for faster output of product with less downtime. The demand for materials that can withstand higher temperatures, accelerated wear, and harsher chemicals allow for a good opening where higher performance plastics can be used in applications. Pictured on the slide is a typical scenario involving a product filler conveyor line. It includes a wide variety of areas where engineered plastics are used, such as filler tubes, tension rods, guide rails, wear strips, star wheels, timing screws. The list is endless. Porosity levels in engineered plastic can be a major concern because porosity creates an opening for bacteria to grow and thus can lead to contamination. This is a common issue with using acetyl homopolymer or Delrin 150. As a general rule, it would be wise to steer away from any plastics containing voids or porosity when it will be used in a food production application. As runtime and speeds are increased, greater levels of wear in parts made from plastics are increased. This might make the need for lubrication requirements in working scenarios all the more important. Using an external lubrication like oil or grease can cause contamination and can be expensive, leading to longer downtimes. In the pictured graph, improper lubrication and contamination are the two largest factors in bearing failure. Utilizing an internally lubricated material such as ZL's 1400T can actually prevent the use of contaminant attracting lubricants and can increase part life. Let's now consider more specific examples of engineered plastics in food processing. Olefins like UHMW and high-density polyethylene are widely used in food processing because of their low cost, wide chemical resistance, their high abrasion resistance, they have very low coefficient of friction, high impact strength, and have very low moisture absorption. But acetyl offers higher temperature performance, including a resistance to steam, better creep resistance, higher strength, superior dimensional stability, and easier machinability. So if a UHMW part fails or degrades more quickly, acetyl would be a logical progression for the part. As it pertains to its use in food production, when comparing acetyl copolymer to acetyl homopolymer, like Delrin, it's important to keep in mind that Delrin homopolymer is inherently porous and increases the potential for bacterial growth and contamination. Acetyl copolymer exhibits minimal to no porosity and outgassing, which eliminates openings for bacteria. Acetyl copolymer also offers improved chemical resistance and better property retention in elevated temperatures and is usually more cost effective. Engineered polyesters like ZL's 1400 PET combine excellent mechanical, electrical, and thermal properties with good chemical resistance and dimensional stability. PET also offers low moisture absorption and has good flow properties. It's an excellent stain-resistant material and is FDA and 3A dairy compliant. ZL1400T is an internally lubricated bearing grade PET containing evenly dispersed solid lubricant. As this graph shows, 1400T exhibits much higher wear resistance, lower coefficient of friction, and the lowest slip stick of all standard engineered plastics. Due to its unique ability to wear against soft metal surfaces, without causing excessive wear on these expensive materials, this FDA compliant material is often used in critical food processing applications. ZL1500 PEEK is a high temperature resistant material which exhibits a unique combination of good bearing and wear resistance, continuous use temperature up to 480 degrees Fahrenheit, heat deflection temperature up to 320 degrees, retains good mechanical properties at high temperatures, excellent chemical resistance, including steam, excellent stability, excellent resistance to high energy radiation, and is FDA compliant. Let's move on to some actual on-the-job examples of engineered plastic at work. Feeder augers and screws and conveyor rollers are very common applications where mechanical plastics like acetyl, nylon, PET, and UH&W are often used in the food production industry. Temperatures and speeds are typically the key factors involved in material selection. When contemplating materials to use in roller applications, ZL's acetyl tube might serve as a good solution for ease of machinability and makes for less material waste. These are two examples where engineered plastic helped to provide a solution for replacement of original OEM parts. The first is the bottle filler tube. It was originally made from metal, but it would break bottles if the line went out of sync. It was switched to nylon, which solved that problem, but it would swell from absorbing too much moisture. Finally, acetyl was utilized and has worked well ever since in this application. Next is a donut filling injector. Acetyl was rigid enough for the thicker jelly fillings, but it didn't damage the donuts when they were being filled. Plus, it could be very easily cleaned for maintenance, and it provided a huge cost savings for the end user. Here are a couple of examples where ZL1400 PET was used specifically as a replacement for metal parts. The first is a piece of equipment that did dough kneading. PET was used as a replacement for stainless steel because of its strength, wear resistance, non-marring qualities when it was mated with metals, and it was FDA compliant, of course. Second was a form die. PET was a replacement for aluminum in this meat forming die. The application required high dimensional stability, the ability of that material to be machined to tight tolerances, it needed to be stain resistant and FDA compliant, and PET fit the bill. In this example situation, a stainless steel piston that weighed 30 pounds was used to dispense tomato paste. It was wearing out very quickly and wearing from metal on metal friction. Replacing the part with PET extended the part's wear life by providing a superior mating surface to rub against the metal shaft. It also reduced the overall part weight and dampened the noise level of the production area. It was stain resistant, increased drive speed and efficiency, and reduced energy consumption and downtime. It was a win-win in this situation. The last application we will consider involved using ZL's 1400T internally lubricated PET. The original part was a stainless steel distribution valve used in the dispensing of condiments like ketchup, mustard, and mayonnaise in one single serving portion. The The problem was that it was wearing too aggressively on the housing surrounding the valve. At first, the company was hesitant to use plastic because they required the material to hold tolerances at 160 to 180 degrees Fahrenheit to prevent leakage. That was until 1400T was tried, and not only did it meet the dimensional stability requirements, but it also improved wear performance and lasted longer. It's also interesting to note that when even higher operating temperatures were required for an application, unfilled PEEK was used, and it served as a superior solution to the original stainless steel valve that was used. Thank you for your time and attention in considering ZL's presentation on engineered plastics used in the food production industry. And as always, we want to thank you for your continued partnership.